Well, students love it. I mean, the hands-on experience it offers students is huge, and they understand that, they get that. I don't think they fully will appreciate it until they leave, but the way they're set up, any student leaving this program going out in industry can open up a control cabinet and it looks the exact same. So it's nothing really fancy, but to some point that's by design. So I think they'll really appreciate it once they get out in industry and they really see how this stuff is installed out in the field and used.
I mean, overall, this is just what I wanted to go to school for a while. I mean, I consider it's not computer programming, but it's a type of computer programming. So that's, I guess, what I look at it as, and feel like I liked computers.
So right now, between the two classrooms that are part of this Automation Instrumentation program, the second year offering, students have their hands on about $2.2 million worth of hardware that you'll see anywhere out in the industry. I guess almost everything I've done with this program, it's been a lot of shooting by the hip. These benches, they started out something completely different and then slowly morphed into what you see today. There was a local business, Iowa Fluid Power, that I basically gave them a sketch on a napkin, and they took my conceptual idea and basically gave me a turnkey solution, I guess. So the main framework of the modular systems is provided. We don't have to assemble anything, which was huge for us because all of the hardware in these new labs was built by either us or work studies. And again, the reason we did that was that if we were to purchase turnkey didactic equipment from manufacturers, our $560-some thousand wouldn't have went very far. Going this route, where we basically bought the raw hardware, bought the raw materials, and put everything together, again using our own labor, work studies, and then just other people on campus, we were able to take our $564,000 and stretch it to the tune of about $2.2 million worth of hardware.
So we have our PLCs, which control a lot of motors and what push buttons, we call them inputs. There's a lot of things for inputs besides just push buttons. And then your outputs could be a light, a motor, some sort of contactor, a solenoid, stuff like that. And so instead of just having a hard wire from a push button to a motor to start it, we use logic that can then help us out based on other things around, such as interlocks or e-stops. So you can have a line of logic in our software, Rockwell software that we use for these Allen Bradleys. And so we can push a button, and then within the logic it will say, okay, turn on this motor. And then if we have an e-stop pushed, or basically like an interlock, so if it's like a cleaning conveyor, if you open a door that has a lock on it, it will turn that conveyor off so you can't hurt yourself when stuff goes on. So it's kind of just a whole bunch of safety while keeping stuff moving. What also it does is going to be, if motors need to run for a certain amount of time, you can put timers and stuff within the logic through the processor to then say, hey, run for 10 minutes, run for this, run for so long after something else turns off and stuff like that.
You know, our dean has seen the reactions of people in industry, but I think once we have like an open house and administration gets a chance to talk directly, you know, within these work areas with people from industry, they'll maybe get a better understanding of what they're actually sitting on, because what the grant allowed us to purchase from a hardware standpoint, there's nothing like it even in the States, as I know, or as far as I know from just a university or community college offering. I mean, what we have is amazing.